Hi guys, so we're going to be talking about the coordinate plane to begin with today. So the coordinate plane is a plane or a graph that's divided into four regions and used for graphing. So we're going to label parts of our plane, and you also have to do this on your assignment today. So for instance, this is the origin, it's the very middle, okay? And the origin is the coordinate point 0, 0, since it's in the very middle. Okay, our quadrants, we start in this top right corner. This is quadrant 1. And then we move to quadrant 2. You go counterclockwise. And they're represented by Roman numerals. And then last we have quadrant 4. Okay, the next thing we're going to label is the x-axis. This line right here, all the way across horizontal, is the x-axis. And then the up and down line is called the y-axis. Okay. Again, your assignment for today also has you labeling these points, okay, or these parts. An ordered pair is a point that's in x and y on your graph. Okay, so the first thing we're going to practice is naming these points. So in here, let's see, A is here, and we're going to name it as an ordered pair, okay? If we start at the origin, if we move to the left, that's negative numbers, so -1, -2, -3. We always move to the left first and then up or down. So then we're going to move up 1, 2, 3, 4. So my ordered pair for A is to the left 3, which is -3, and then up 4, which is +4. Okay. And that is in quadrant 2. Point B is here. So starting at the origin, if I have to move to the right 2, that's going to be +2. And then if I move down, that's negative. So it's -3. And that is in quadrant 4. Point C is right here on the y-axis. So if I start here, I don't have to move to the left or to the right any. All I have to do is move up 2 to get to C. So if I didn't move left or right at all, I have 0 as my x value and up 2, so +2. Okay. So since this is not technically in a quadrant, we're just going to write that it's on the y-axis. Next is point D. So start from the origin. We move to the right 3, so that's +3, and then up 1 to get to D. And that is in quadrant 1. Okay. Point E is here. Starting from the origin, I need you to tell me the directions to get to E. So I'm going to move to the left 2, and whenever I move to the left, it's negative. And then I'm going to move down 3. Okay. And that's in quadrant 3. Quadrant 1, 2, 3, and 4. Okay. And then quadrant F, not quadrant F, point F is right here. And starting from the origin, to get there, I need to move to the right 5. So that's positive 5. And then I'm already at F, so I don't have to move up or down at all to get there. And this point is on the x-axis, not in a specific quadrant. Okay. So remember, when you are moving to the left, or if you're moving down, these are going to be negative. If you're moving to the right or up, these are going to be positive. Okay. The next few are some just definitions. For the discrete graph, this just means it's a graph of distinct points. Okay, and it could look like this. So here's my graph, and then I might have just distinct points. It's not necessarily a line. Well, that looks like 2. But okay, they could just be all over the place. And then a continuous graph is a graph connected with lines and curves. And it could look like a line. It could look like squiggly line. There are all tons of possibilities. Okay. The next part, we're going to start talking about relations. Okay. And a relation is a set of ordered pairs. The x values is called the domain. The set of all y values is called the range. Okay. If your x values repeat, it is not a function. Okay, so our first example is this set of ordered pairs right here. I have -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Okay, so each ordered pair has an x and a y value. The first one is always x and the second one is always y. So I like to label these as x and y's before I begin, because I know that my domain are the x's and my range are the y's. So for the domain, I just need to list all of these x values. Okay? And it looks better when we list them from least to greatest. Okay? Notice that I didn't write this -3 because it's already right here in the list anyways. So if you have it happening more than once, you do not have to write it again. Okay? So that takes care of my domain. Now I need to write the range. I need the y values. Okay? Again, it looks better if it's written least to greatest. Okay? let's see, so -4, 0, 1, 2, and 5. I took all of the numbers that I circled and I put them in order from least to greatest. Okay, now you can also write a relation as a table. Okay, so you're just putting the x and y's together, stacked in a table. So I'm going to write each one of these in the table. So -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Okay, so that's the table. That's all you have to do. Again, if your x values repeat in a table, that shows you that it's not a function. So since our -3's repeat in this x column only, I don't care about the y's, just the x values. If they repeat, this is not a function. Okay. The next part is this mapping, and to draw the mapping, I like to use my ordered pairs or my domain and range and my table. So to set this up, your x values go on the left and your y values go on the right, and I'm going to list them exactly how we have them here in the domain and range. So I have -3, -2, 1, and 3 in my domain for my x values, and the y for the range I have -4, 0, 1, 2, and 5. Okay, so now from there, I'm going to use my table to draw my arrows because I know that -3 goes to 1. So I'm going to draw -3 to 1. And then -2 goes to 0. So I'm going to draw that one. And then I know that 1 goes to 2. And 3 goes to -4. And last but not least, -3 goes to 5. Okay, so for this mapping, you see how there's two arrows coming out of the -3 right here? That tells me that this is not a function, so that's how you would see it on a map. Okay, if if two arrows, or if each number doesn't have two arrows coming out of it, then it is not, well, sorry. If there's any number with two arrows coming out of it, or even 3, then it's not a function. Okay, so for this graph, I like to just use the table because I like things to be more organized. So I'm going to plot each of these points. So -3, 1, 2, 3, +1, so there's a point. -2, 0, 1, 2, 3, -4, and -3, 5. Okay, so again, and this is not a function because it does not pass that vertical line test. Because if you were to draw a straight line, it would go through more than one point at the same time. Okay. Our second one, again, I like to label these as x and y's. Okay, so my domain are the x values. I write them in order, -2, -1, 0, 2, and 5. And since none of these repeated themselves, this is going to be a function. Yes, function. Okay, and then for the range is the y values. So I'm going to circle them so my eyes focus on them. And then I write them from least to greatest, -3, -1, Oh, I have a -2 before that. -2, -1, and 4. Again, these repeat, so I'm not going to write it twice, but that has nothing to do with whether or not it's a function. Okay, if your y values repeat, that's perfectly fine. If it's a function, it's only according to your x values. Okay, all right, let's put this in a table. So -2, -3, -1, 4, 0, -2, 2, 4, and 5, -1. So if we put this in our mapping, we have our x and y values. I'm going to use the domain and range to write them in order. All right, and then the range, I have -3, -2, -1, and 4. And then I use the table to tell me where to draw my arrows. So -2 goes to -3, -1 goes to 4, 0 goes to -2, 2 goes to 4, 5 goes to -1. Okay, notice that again here you have y values, like this 4 right here has 2 arrows going into it, but that's okay. As long as when you look at your x values, you have 1 arrow coming from each of the numbers, it's still a function. Okay, now let's represent this on a graph. So I have -2, -3, -1, +4, 0, -2, 2, +4, and 5, -1. Okay. All right, in this last row, we're going to kind of work backwards. So we need to label these points on this graph before we can put them in a mapping. -2, 3, -5, -4, 0, -3 is right here. 2, -5 is right here. And 4, 2. Okay. So my x's and my y's go in my mapping. So the x values are the first numbers. So -5, -2, 0, 2, and 4. Okay, and then the y values are the second numbers. I like to write them in order still. So -5, -4, -3, 2, and 3. And then my arrows. -5 goes to -4. -2 goes to 3. 0 goes to -3. 2 goes to -5. And 4 goes to 2. Okay, so when I write those in the table, I have -5, -4, -2, 3, 0, -3, 2, -5, and 4, 2. I'm basically just copying it from that graph. Now the domain is all the x values. And then y's are for the range. Nope, I didn't write them in order. Okay, so those are the range. And then last, I need to say that this is a function. So yes, it is a function because my y's are not repeating. and then write them as their ordered pairs. Okay, and that's all.